This conference will now be recorded.
Hi, very good morning and good evening, everyone. Welcome back. So last session we were discussing about so the pretty basic introduction to Docker, right? So we are going to continue the same thing. All right. So the Docker part. So yesterday I think the Docker commands basically so the Docker command wise we just talked about Docker Docker imaging. Okay, how do you pull your images? And while you are pulling the images, basically, so what all the things you have to keep in mind, like versions. Okay, so what are the versions and how do you manage those particular versions and what versions is called in Docker? So we just talked about it is simply tags. Okay, and okay, so here is where we talked about those options, and now we are going to create our containers. And in fact, we talked about creating the container yesterday. So just by using Docker run, and then and in Nginx you can just do the image name. But if you want to run it in the background, so then you have to go with the -d option. Okay, so -d is actually going to run in the background, and it's Docker PS. All right, so this is how so this is how you okay, you start with, and we are going to talk about different options in Docker run. Okay, so first thing is if you run a service, basically how do you expose the port? Okay, so that's first thing we're going to talk about. Let me go to my workstation, turn on my workstation. Sorry, yeah. So let's connect to this box. Yeah. So Docker PS. So now let's say if I give Docker PS is going to show you only the containers which are running, and Docker PS -a. So certain containers might be into exited state. So due to its job is done, or you restarted your system. Um, so those containers didn't started automatically. Okay, so whatever the scenario it is, okay, so these containers are in stop state or another state which is not in the running state, and Docker PS can show only the running containers. Docker PS -a is what it shows the other containers basically. So the Docker PS okay, Docker PS and Docker PS -a. So two commands we have. All right, so that is another thing. And the next thing is I will go and give Docker run. I will just go and give Docker run -d, and then you just give the image name. Okay, so Docker run or Docker PS. Docker ps-e or Docker ps also shows that particular container. Now there is an nginx running here. Okay, how do you know that there is an nginx running here? If you hit that particular container and it gives a HTML response, then you can say that yes, something is running there. So now how do I hit that? So every container you create, you're going to get a container ID. Okay, so so basically every container we create, we get a container ID. Okay, so basically you can also overcome that particular. You can also override that particular and also container ID and container name. Okay, container name also will come at the ending. So there is some dictionary words it uses and actually keep like this. Okay. Now if you want to give your own name, okay, so we can give custom name. We can give so custom name using hyphen name option. Okay, so using a hyphen name option, so we kind of I mean, we can give the custom name using hyphen name option. All right, and so the next thing is so you can give hyphen name. So Docker run, okay, -d, and then hyphen name, and then like let's say nginx, and the image name is also nginx. So Docker PS, you can see the nginx, and so the name of the container becomes as nginx. All right. So this is how you can do that. Now you can get the container low level information using Docker, using what? Docker inspect option, inspect. Okay, using Docker inspect. Using Docker inspect, you get it. All right. So how do we do the Docker inspect? And just you Docker inspect, and then you can give the name or you give the container ID. Okay, anything is okay. So in nginx, now you get the low level information. So that means all the information about your container. Now at the ending, usually you'll see the IP address. Now you take the IP address and you give this call and you hit it, you are getting the welcome to nginx. So some HTML response you are getting. Some HTML response you are getting, and this HTML response and some HTML response, whatever you're getting, so this HTML response you're getting from the container, and this is accessible only inside the container. You cannot actually access outside of the container. So that means, okay, so the server is actually running this particular this server is actually running this particular container, so you cannot actually hit the server to get this response. Okay, so by default, now we need to handle that as well. So let's see how do we handle that. Okay, so so let's see how do we handle this particular part. Now I want to publish a port, so then the Docker, you have to do the port expose. Now while you do the port expose, it can be done in two ways basically. Okay, so port expose can be done in two ways. So one is dynamic way. So port expose can be done in two ways. Okay, so one okay, two ways, dynamic and static ports. Dynamic and static ports. Okay, and so dynamic and static ports. Okay, so can be done in two ways. So which is dynamic and static. Okay, so dynamically. Hey, Manoj, you are actually having some problem. Yeah. So here, yeah, port expose can be done in two ways. So dynamic and static ports. So dynamic ports ranges from uh, Docker dynamic port range. Okay, some 30. Okay, so the default ephemeral port range for your Docker is 49,000. Mm, we might be getting something else. Container service, no. Wait, get that information. Okay, let's see, and we will make it. But this is more of Docker ECS. The default ephemeral port range is 49,000. This one that we used before. Let's see if that information is correct or not. We get it. So here, dynamic port ranges from something. Okay, so to open dynamic port, dynamic port, we have hyphen capital B option. Okay, so use hyphen B option and then it opens dynamically. Okay, capital. So now I'll just go and give docker run hyphen D and hyphen capital P, and I'll just give nginx. So now docker ps, so it just opens one port. Yeah, 14, it seems it's correct only. So it actually opened 49153. Okay, I thought 39153. It's actually 49153. It started with that port only, if you see. Okay, it started with that port only. So 49153 to 65535. 65535. Okay, so dynamic port ranges from, automatically it opens one port. So that means if I go and hit my server now on that particular port 49153, now you're getting the response. You're actually getting the response from the container. Okay, actually getting the response from container. So this is what you can open a dynamic port. Okay, so this is the dynamic port opening. All right. So, and you can open, you can just run one more Nginx also. You can run, or like say you can run a web server as well, HTTPD. HTTPD is Apache web server. Okay, so just give docker ps, just runs everything. Now actually the web server is 49155. So you're getting it works response from Apache web server. So you can run multiple containers like that, and so it just opens a different port. Okay, so sometimes we want a specific port. Okay, so I can tell to my docker that, hey, use this particular port. Okay, so then you can specify your static port. So static port um, can be given with -p option, with the -p. So which is so host port colon container Okay, so all right, so static port can be given as -p. Okay, and then you do that. All right, so you can just do this. So now docker run -d nginx. So, and first of all -p. So 80:80. So I'm telling I want to run 80:80. I'll just go with nginx. So now what is happening? So Docker is actually opening a particular port which is 80 on the system and pointing to the 80 of the container. All the container side all the time if the port is same, on the server side it is changing. Now you cannot actually run one more container with the same port opening because yeah, the port is already in use. Okay, it tells you that port is already in use. So that's where you can use only one port. Okay, so this is how you can so open certain ports with the you can open some certain ports with the container. So yeah, dynamically or statically you can open certain ports, and it's your scenario that how you do that. Okay, clear? Any questions? Yeah. So the next thing which is going to be here is Docker volume mapping. Okay, how do you map your volumes with your Docker? So that means sometimes we need some persistent data. So now, as of now, you're just using so stateless applications like Nginx. Now I can go for stateful applications like MySQL, like let's say. Okay, so Docker run rather than MySQL, I'll prefer to go with MariaDB. MariaDB also needs some bugs for that. I would like to go with MongoDB. Okay, so Docker run, okay, -d MongoDB. Okay, so Docker run -d Mongo. Okay, so Docker PS, and there's a MongoDB running. Now, if I want to remove all these containers, basically Docker RM, and you can give these multiple container IDs. Okay, one by one. But those are actually in running state, so that's the reason I want to forcefully do that. -f. Okay. Now, if I want to remove all the containers at a single shot, so then I can go and give Docker, or the command substitution already, right? So you can go for command substitution, so which is this, and Docker RM and Docker PS -a -q. And if you technically want to know what is happening here, so Docker PS -a -q, what it does is it just brings all the containers. Okay. Now all the containers you are passing it to rm -m, and it will remove all the containers. Okay. So if I want you to have some information, then here it is. Docker RM and Docker RM -f. So these are also options which you have. If you want to remove all containers, so then you have this. Okay. All right. So I just cleaned up everything, so I can just give. All right. So Docker run -d Mongo. So I have a Mongo container running. So Docker PS, Docker PS. So Docker run, or okay. So now I want to execute some commands inside a running container. I want to execute some commands inside a running container. So Docker exec -it. Okay, interactively, I want to go inside the container, this container ID, and I would like to say bash. Now what actually I'm doing, so here I'm actually logging inside the container. So telling I want a shell, it is giving you the shell. Or you want to execute some other command, like let's say you want to execute ls command inside the container, you execute ls command. I'm asking for bash, you're getting a shell. Okay, so to get into a container, use these particular commands as well. Okay, so I can say this as id, and this changes all the time, right? So yeah, Now I can go and give Mongo. So Mongo is a so thing it is actually, and I can go for show collections. Okay, so show collections, I don't have anything. Okay, or show DBS. Sorry. So show DBS to show the databases. It is showing by default there are 3 databases. Now I want to create one database. Okay, so create database Mongo shell. So from Mongo shell, so how do I create a database? Show DBS to show the databases. So use automatically it's gonna create it. So use something like this. If I give, it's automatically so show DBS. Show DBS will not be there. So basically you just started creating an empty database. So if you want to save that, actually you can just go and give some command here, like something like this. You just insert something and now you give show DBS. So it shows that there is a show DBS. So there is some new database coming out. Okay, I'm pressing Control D to come out. So Control D to come out. Okay, so now if I relog into this particular one, I can directly give Mongo also. I can go into the shell and now give show DBS. Okay, you're getting it. Okay, so now Docker rm-f, if I remove all the containers and if I launch one more container, and if you launch one more container, okay, Docker. So Docker run Docker exec. So Docker exec -it. Okay, you do this and you can say go for Mongo and show DBS. The database is gone. Okay, now container storage is ephemeral. Okay, ephemeral means like this. Ephemeral meaning ephemeral. If you see the image, you will understand ephemeral. Okay, so ephemeral image is something like this. Right? So basically, this is ephemeral. Okay, the life of this is very short. The life of this is very short actually, right? So now it can contain until it has some life, right? So but once it is blasted, it lost everything basically, right? So that's basically ephemeral. Okay, or even if you see the basically this one is also is a quite good example for ephemeral. So it is the life is very short unless until the water comes, so it is alive and after that it's gone. The same way, like unless until you get the container deletion, okay, you have the so it holds the data, and once after container is deleted, it removes all the data whatever it has. Okay, so that's where that is called as, or that's treated as ephemeral. Now now the next thing, so which you and the next thing which you want to do here is and the next thing which we wanted to do is I want to store a persistent data. I don't want to lose the data, even though I lost my container. So I don't want to lose the data. So that's where volume mapping coming into picture, and so that's where starting. Okay. So now the volume mapping coming into picture. Okay, so containers are ephemeral. And hence the life of them is very and I mean ephemeral means it's, and hence we lose the data, and hence we lose the data if container is deleted. Okay, so and in cases basically in cases we need to have the data persistent even if we host or remove the container. So that's the major point. Okay, so if even in case if actually I want to remove the container or it actually accidentally deleted whatever the reason, I don't want to lose the data. Okay, so how do we do that? Okay, so how do you do that is by using volume mapping. So how do you do that? So now you are actually creating some Mongo databases. It actually goes and stores in certain place. Okay, where that is storing. Okay, so where the data actually stores, you can get that information from Docker Hub, hub.docker.com. If you go for and you search for Mongo, they provide the documentation basically. So this is the image which you pulled, and so they tell you, persistent. If you search for basically volume, yeah. So now you can see this. Okay, you know so created a directory zone, and so you can see this one. So it is your host directory and it is your container directory. Okay, but whatever it is, how do you handle that is with the option of -v. Okay, so a volume of host machine can be mapped to a container. A volume of the host machine can be mapped to a container using -v option. Okay, so this is the option. Host path, container path. Okay, so yeah, this is how it is. Now I can just go and give docker run -d mongodb and -v volume, like let's say /opt directory. Okay, or like let's say mkdir data. Here only I'm making it. So docker run -d, okay, -volumes, which is a /home/CentOS/data:/data/db. Okay, if I'm not wrong, there is a path that Mongo is telling. Okay, so if you go with other image, they tell their own path. If you go to MySQL, they might tell you where lib MySQL. Okay, something like that. Okay, so which is Mongo. Now you do this. Okay, so docker ps, you have the new container. So then you can go and give docker rm, or basically rm-f. Let's remove everything, then run once again. Let's map it once again, and docker ps. Now just go with the container ID. Docker run not run exec, basically -it, this one, and so it actually goes with bash. It goes with bash, huh? No, I'll go with Mongo. So what are the two commands to create the database? Like let's say use sample, and you can just, like let's say use Raghu, it just creates the database and you put some result, and now show databases. So you have that Raghu database also. Now you come out and you remove rm-f, remove everything, and run -d. You run the container once again. So docker, there is a new container which got created, docker ps, and you can just go and give docker exec -it, docker exec -it, so which is this one, and you go for Mongo, and you go for show dbs. So you see the Raghu database is still there. Okay, until when you have that particular data, so you have this data directory until you have the data available inside this location. Okay, the data is available. Okay, the data is available. So this is how you store the persistent data of your container basically. But if you go into the Kubernetes, you will get a lot many options. Not only this, you'll get more options there, but behind the scene, this is what is happening. Okay, right? Clear? Any questions? Yeah.
Delete the your database name content in the database, the persistent data will be deleted from the database.
Yeah, obviously, right. If you delete the data of the database, it will be deleted.
Okay.
Okay, all right. So the next thing, so which we have is Docker environment variables. Okay. So Docker environment variables. So ultimately, we need to pass some variables. So we can pass some information to the containers using variables. Okay, so most of the modern applications uses variables rather than having a config file rather than having a config file. So most of the modern applications basically will use variables, and that's where variable takes a lot of importance here. And how do you pass? It's quite simple. We can pass from a file. We can pass either directly or from a file. Okay, so we can pass environment variables. Okay, either directly or from a file. So both you can do. And how do you do that basically? Okay, so let me show you. So I can go for docker run -d. No hyphen d is not really needed, because hyphen d is mostly for services to run in the background, but I'm not running any kind of service now. So docker run CentOS :7, and I'm going to give env. So CentOS 7 is a base image of CentOS, and I'm executing a command called as env, and it's giving me this particular response. You see this? It's actually giving me 3 environment variables. Okay, fine. Now, if I want to pass my own variables, so then docker -e. So like, let's say URL is equal to google.com. So now you're getting URL equal to google.com. Okay. Right. So URL is equal to google.com. And the next thing, you can give multiple environment variables also. Now, -e, like let's say site is equal to USA. Something like this. Okay, so whatever it is, you got that particular variables, right? You can pass them. Or else what can be done, you can pass it from a file, right? So that's what I'm mentioning. So cat actually, docker run -help. You can just go for environment from file, also something will be there. So environment file. Okay, so read the file from the environment, read a file of environment variables. Okay, so which it is so docker run or vim env. So URL is equal to yahoo.com, and the site is equal to India. Okay, something like this. So now docker run -e environment file, so which is a /env file, and I'll go for CentOS :7 and then env. Okay, now you can see these two values. Okay, so URL is equal to yahoo.com and site is equal to India. Okay, so but actually coming from a file. So these are the two options which you have. Okay, so we can so parse directly using -e option, and parse from a file using -environment -file option. Okay, so these are the two things which you are having. Okay, so this is what So this is what you are okay going to have in environment, okay, and passing the environment. So this is how you do that. All right, and hopefully there won't be much confusions around there, but yeah. So the next thing, so which you have here is container resources. If I want to limit some if I want to limit some resources, then how do I do that? So you already know some stress command, how do I increase some load and do that, right? So the same way, I just want to use some same stress command, but I want to use for memory rather than loading. Okay, I would like to say it as rather than I would like to so say it as go on the memory side. Okay, how do I do that? First of all, okay, so just go and give docker run. Now I don't want it in a detached mode, so I can go for IT and CentOS. If I want to make interactive, then IT. If I want to run in background, so then -d. So bash. Okay, so here you're having what you're having cd. Okay, you're just inside the container. Now I'll go and give yum install stress. Let me try. So I install EPL packages. From EPL, you're going to get stress. Okay, and the stress basically --help. Okay, so this is what I have, and so now you can see this. I cannot run this. Basically, it will immediately fail. Oh no, it will not fail. Why? Because the VM actually, the memory you're consuming only 128 megabytes, and so that to be with 2 times. So that means 250. So let's say if I make it 200 times, so then it will crash immediately, saying that it cannot allocate the memory. You see this? But if you make it this is a 1 GB machine, unless until so if I am under 1 GB, so it will always be fine. Okay, like let's say if I say 1024 MB, you try to consume for one chunk, 1024 MB you consume for one chunk and use one chunk only, so it will try to hold that. Okay, because it has 1 GB memory and it can kind of hold that. Okay, but if I go for some like let's say 3 GB or 5 GB, it will not be able to handle. It will immediately say that it doesn't have any kind of memory, so it's actually so something is actually failing, right? Okay, or even I can go for a little bit more seconds, so like 60 seconds if I say. So for 60 seconds it cannot hold because it doesn't have those many resources. Or in fact, actually, if you want to get the real memory, real answer, yeah, this is fine. Okay, so this is what you have. If I go for 50 ultimately, so yeah, cannot allocate memory, right? So if I'm under boundaries, I'm okay. I'll not get that particular error. So now if I'm giving 1 GB and I'm taking so for a time of 60 seconds, it can hold. Okay, that means this container can use my whole resources. Okay, let's go back there. So free -yum. Now you can see this. I have almost 2 GB of memory. Okay, which is fine. That's okay. Now if you go beyond 2 GB, you will not be able to. So then how do I limit these particular resources? So because every container can consume all my resources. Okay, but I don't want to do that. Why? Because sometimes a container having an issue, it tries to start consuming more resources. It just give problem to the other containers. Okay, and we don't want to do that. Okay, so that's where I will give docker run -d. No, docker run not -d. Docker run -help. Docker run --help. So if you come to the resources, basically you're going to have --memory, the memory limit of how much you want to give. Okay, so that's where I would like to give Docker run --memory, and I want to give only, like, 256 MB. Okay, 256 MB -IT. So CentOS :7 and then dash. So now I'm taking some memory limit and I'm actually going here. So yum install epel -. So you see this, it is very slow as well because it doesn't have much memory, right? So it is very slow. Installations, processing is a bit slow here. Yeah. So now you go for stress -help. So stress -VM to, okay, if I give 256 MB, okay, and a -- timeout and 60 seconds, it will fail immediately. Why? Because it doesn't have 256. Okay, so 256 into 2, 512 MB of RAM it doesn't have. But whereas if I give kind of 1, okay, and you can just see that it actually can hold a little bit, but I think even 256 also it cannot hold. Did I create it with 256 only? I think so. Yeah. So 256 means you might not be getting completely 256. Like, let's say if I give some 200, so it can withhold that particular stress basically. Okay. Some little bit are less reduced, because memory, you know that all the time you'll not get 100%. Right. So some percent will go away. So now you see this, it's actually holding it up. Okay. Anything you go beyond. So like, let's say if I want to go 2 times, which is 400 MB, my actually stress command will not withhold it. It will just fail it on its own. Okay. So you can just consume, you can give the resource limits by using okay, resource limits by using hyphen CPU and hyphen memory basically. Okay. So now what is the importance of this is some scenarios. In some scenarios, okay, so are basically containers by default. Okay, consume all CPU and memory of the host machine. So of the host machine. Hey Manoj, you are actually accidentally unmuting so many times a day. Please take a look. So please don't unmute unless until you want to really talk. Just cause some noise.
Yeah, sorry, yeah.
Thank you.
My internet connectivity is a bit.
I observed that. Yeah, I observed that already. But yeah, please. Thank you. And yeah. So containers by default consume all CPU and memory of the host machines. Okay. So this is really nice feature. So nice feature where VMs cannot do this. Okay, you cannot actually share the resources between 2 virtual machines. Okay, so that's where it's a very beautiful advantage actually with the containers. But the problem here is, at the same time, the problem arises is the problem that arises here is what is the problem that arises here is so certain containers which are okay, so which are not supposed to okay, consume the resources and starts consuming and starts using more resources, okay, due to a bug or some performance issues, then the other containers so starts facing lack of resources. If one container is actually eating all the resources, the other containers cannot actually start using it. So other containers are supposed to be using the resources because those are good, but still, so due to one container it is bad, and okay, so we cannot actually, other containers cannot start. It actually will not get the resources to perform. So to avoid such cases, okay, so we always give resource limitations, and give what much can be given, what much is needed, give what much is needed for that. Okay, so always you try to give that. Okay, so hyphen CPU and hyphen memory are the options can be used, to use resources to control the resources. Okay, so this is what you have in resources. So hyphen CPU also, how much percentage you want to give, like you can give that. Okay. Okay, so this is about container resources, right? Any questions? Yeah, okay. So the next thing is the self-healing of the container. Now let's say I put an engineering service, I rebooted the machine, or engineering service has been crashed due to some reason. Okay, I cannot run behind and starting the containers, right? It has to automatically start. Okay, so container has that particular capability. Okay, so containers has a capability of so self-healing. Okay, so containers have a capability of self healing by doing a auto restart. Okay, by doing a auto restart. So yeah, by doing the auto restart, it has the capability to self heal, right? If like most of the problems in IT world basically will be solved by restarting the things. Okay, so no one knows the reasons, but basically you restart it, so all of a sudden it starts working. Okay, that's everyone knows that, right? So basically, at least in the backend industry or backend people definitely knows this. You start restarting a service, then it starts working. Okay, so why what, later analyzations, but container has to self heal itself. There is a problem. Okay, it has to okay, so restart itself. So how it can happen? Okay, how it can happen? So yeah, so that's where the health checks comes into picture. And but basically, sometimes, not sometimes, if you want to restart automatically on a container exit status. Okay, if container exited with some status, and if you want to container if you want to automatically restart on a container so exit, then we can use a hyphen always what is that option? Docker run hyphen help hyphen restart, if I'm not wrong. Yeah, hyphen restart. The restart actually is a string. You can go with so what all the strings you have. So man space docker run. If I go with the manual pages, hyphen restart, it just shows a little bit documentation. So restart actually telling it's actually not giving any kind of information. Here you have box. Okay, so you see this, you're having okay, so hyphen restart is no. That means do not automatically restart the container if it exists. On failure, okay, restart only if the container exists a non-zero exit status, then only you do that. Or restart always. Always means unless until so you kind of unless until so irrespective of whatever the scenario, you want to restart the container all the time if it goes down, then always. And unless stopped. Unless stopped means sometimes you want to stop the container, so then you go and give unless stop so that you can go with that. Okay, so these are the scenarios on the outside side. Okay, on the outside, if the container is stopped, you want to start it, so these are the options basically. Okay, so that means you can just give docker run hyphen restart, and if I give always, and so CentOS 7 and sleep for 10 seconds. Okay, so sleep 10, how much time it will run? It will run for 10 seconds and actually will be down. Okay, so then what this container restart always will happen here is, so docker ps, if you see, actually again it started, you see this up 2 seconds back again. Okay, so docker ps up 9 seconds, and again you give docker ps, again it became 2 seconds. So that means it's going down and again being brought up, going down, being brought up. Okay, so irrespective of any scenario you have, okay, if you want to start it back, so then you have always option. Likewise, you have on failure, unless stopped, so these scenarios are there. But these are black box related things, so that means you're actually looking outside of the box and starting it up. Okay, so but most of the scenarios you cannot actually go with the black box. Okay, so you need to restart based on some inside metrics. Okay, so that's where these health checks, all additional health checks comes into picture. So now you can have a health command. So it actually going to run the health command, and based on the response of the health command, okay, it actually going to restart it. Okay, so for example, so docker run -d, and then so CentOS 11, and sleep I'll keep a long time, some 1000, whatever it is. Okay, it's running, right? So you can see docker ps, it runs. Okay, fine. Now I want to run with a health check saying that so hyphen health command, and I wanted to give so ls command, and ls command always gives exit status 0, so which docker ps, it will never go for a restart basically. So health check is starting basically. You just need to, just after next run it will tell you so whether it is running. There is a interval time also there, right? How much interval it actually takes. So 0 seconds, start period duration also 0 seconds. Immediately it is all starting. If you want to increase this things also, you can do that. So docker ps, it has to start actually. It's still telling, it may take some time. Yeah, now it is telling it is healthy, because ls command always gives healthy response. But I want to go and give docker exec -it, this one, and I want to go and say bash. Okay, so type ls command, and okay, rm hyphen I know the path basically, hyphen ls. So now you start understanding this, so docker ps. So actually going to check the health check. So now the ls command actually is going to give you a no command not found error. You see this, you're not getting that output. So that docker also will do that same thing, and it will go and restart it. It will just observe. So in the default given interval of time, So let me check Docker run. So still it is healthy. Okay, so what is this guy doing? Yeah, now you see this unhealthy. So you can tune these intervals basically by using those health options, right? So you can just tune these a healthy option, tuning the intervals basically make response a bit faster. Okay, so that's what you can do. So now it actually came to unhealthy automatically, so again in some time it actually does the restart. Okay, so that's what is the scenarios. Okay, so hyphen. So you can, if you want to restart automatically on a container exit, then you can go for restart. And if you want to, so restart based on health check, then we use. If you want to restart based on health check, okay, if you want to restart based on health check, then we use what? If you want to restart based on health check, then we use a hyphen health hyphen cmd. Okay, so this is what this is what we have. Okay, on the health check side. So probably in the meantime, if I go and give Docker PS, it's showing unhealthy, it's not getting restarted. So there is something, the retrace option basically is there. So the retry option, if you say one time, so then automatically, after one restart or one healthy state, actually it's gonna restart it. Okay, so here interval, the health retries integer. Okay, so this is actually not telling, how many consecutive failures, after how many consecutive failures it actually consider as a restart. Okay, so but whatever it is, this is what you have. All right, and so that's health checks. It's mostly done through Kubernetes layers. Okay, but you need to understand something here. And that leads us mostly to the end of the options, what we really require on the Docker run side. Okay, so basically Docker run help and help. So I'm expecting mostly every option is not really needed, so you can just look about it whenever you need it. DNS CMD expose. Okay, health, and then memory. Yeah, mostly that's it. That's fine. Okay, so those options are fine, and yeah, we're good to go. Okay. Yeah. Any questions? All right. So the next thing. Yeah, go ahead. Sorry.
So we have to create DNS records to get available for outside the world for every Docker.
No. Docker, you don't go with the DNS records. So still it runs on the host machines, right? So actually, if you see the project, you will come to know at the end of the day. A load balancer, still you use it, right? So however we use on the server side, we use a load balancer, but never use the DNS for the machines. Basically, we're using already all the time on the load balancer. So when you come to the Kubernetes platform, also you kind of go with the load balancer. So DNS records for containers is necessarily not needed. And the next thing, so which we have is a Docker imaging. So far you're actually using, so some images from internet. But if I want to make my own images, because my project, my application, my image, right? So we need to have that way. So then in that particular case, so how do we do that? In that particular case, how do we do that? So that is the next thing we're going to discuss. So which is, there's the next thing which we're going to discuss. So which is, sorry, there's the next thing which we are going to discuss, which is a Docker imaging part. Okay, so Docker imaging can be made through a Docker file. A simple declarative file is being offered by Docker. So the whole ecosystem, as I'm mentioning, okay, Docker file is one of the one, so which makes Docker as famous. Okay, so is one of the component which makes your life really easy, and making the images are really easy here. Okay, but how do we deal with this? Okay, so that's what we are going to talk now. Okay, so the syntax of the Docker file is going to be given as you can go for Docker file reference. So Docker file reference, you get the directly Docker file reference documentation from Docker, and on the right side you have certain options, and we'll be using them. So from and run cmd, so different things, we'll be using different things, and we'll run it. Okay, so let's go to, so the syntax is actually of the Docker file is actually going to be instruction and then arguments. So instruction is nothing but this from, run, cmd, all some certain instructions are there, and those instructions are going to use, those instructions are predefined, and the arguments you are going to pass it as per your requirement. Okay, and once after you run the Docker build or Docker run, you go with the Docker build, and yeah, so you can do that. So I'll get into there. But mostly first starts with Docker file. So I will go to the box. So from is the first instruction we are going to use usually in the Docker file. So if you want to make any Docker image, you should use some of the source image. You should use some of its source image. Okay, so the source image I'm using is CentOS. So now your images are made using this particular image, and on top of that, they are going to build that particular. They are going to build this particular images. Okay, so this is what. So this is what the from instruction is going to be. So from is actually going to take one base image, and using that particular base image, you're going to make the remaining images. Okay, all right. So that's first thing, and so fine. Now I can just convert this into my own image. So you put that. Now I'm going to use a Docker, like Docker build. Sorry, Docker build -t. You can give some image name, like let's say sample, and you can give dot. Dot is the location where your whole, so the content which is available for your Docker image to make it. Okay, so even the Docker file basically. Okay, ls. So you have this one, right? So Docker images, you have this particular image, like this one, right? So you're just using this particular image from CentOS 7, and you're using it. And the next thing which is okay, so usually you change certain things in the images and you make build it. Okay, and second thing before to that is, so when you're actually making the images, you have to make an image according to your Docker registry. So the Docker registry I'm going to use here is a Docker Hub. In my Docker Hub, if you are using, so the Docker Hub you have to use docker.io is the Docker Hub image location, registry name /username /image::tag. Okay, by default it is using tags. So docker build and docker.io slash, even though actually if you try to pull docker pull CentOS colon, yeah, now if you see this, actually it is library, it's actually not telling you. You see this is actually from the this one docker.io slash library slash CentOS colon latest. This is the whole path of that. Okay, or even in a shortcut you can give docker, while you build it, basically what you can give, your image name has to be docker.io slash my username is this, already I have that, and slash, like let's say d53 test, let's say v1 and dot. So now the image is actually made in the in this one. Now I can push this particular image. So how do I push? Docker push this particular one. Ultimately it is going to fail. Ultimately it's going to fail. Why? Because it doesn't have a login, right? It doesn't have a login. Ultimately it's going to be a failure. Ultimately it's going to fail. Why? Because it doesn't have a login. So docker login. Okay, it asks for the username, give the username, password, your password, then it says login succeeded. Then I can go and give docker push this one, you do that. Whereas GitHub introduced recently a GitHub Docker registry also, GitHub Docker registry. Okay, so if you want to put to so GitHub Docker registry. So if you want to put images into GitHub, so here also you should start so your own imaging, but the imaging has to be done by using so ghcr.io slash your username slash your application name or image name and colon version. So this is what you have to do. Okay, so this is the another way of so this is another registry. So that's where so you have this one, or if you're actually Amazon has something called as ECR, okay, container registry. Okay, so ECR, container registry service. Yeah, container registry service. So if you go with this container, then what you will be doing is you will be using some format, whatever that Amazon is telling you. Okay, depends upon that. So since we are using Docker Hub, so we are actually okay with this, right? So first step is done. So you know how to make your images. Starts with Docker file and basically keeping so from instruction. Let's go one by one instruction there. This one. So from instruction is done, and then the next instruction is run. So now let's say if you want to run some commands during you make your images. So so vim docker file and so run, like let's say yum install httpd-y. Okay, I want to install a web server inside that, which is a httpd, and so now I can go with installation of web server. Okay, so you want to run any commands to do something inside the Docker image, then you go for run instruction. That's it, nothing more than that. Okay, so CMD. Now let's say if I launch this container, I want to start a web server. If I want to launch this, if I launch a container using this image, whatever the image I made it should start a web server. So how do you tell that it should start the web server is by CMD. So the CMD is actually the one which is going to tell that the default command which it is supposed to run if someone uses a container run by Docker run by using our image, then what is the default command it is supposed to run is given as this one. Okay, the foreground. So this is the process, this is the command to start your web server, and you can go and build this. Okay, now if I just give Docker run this one, Docker ps, you can have our image running and Docker inspect, do this and just take this IP address curl, and if you give this, you're getting the web server response. So this is the default response which you are getting it from the web server. Okay, makes sense, right? So that's how, okay, so you can deal with it. So CMD is actually going to be the default command which you want to run. Okay, so default command which we are going to run when you run the container basically. Okay, run is the instruction which runs the commands while you make the Docker build. When you make the Docker build, those commands will run and run. But CMD is when the person actually do Docker run using that image, that time the command will get executed. So that's the difference. And label is that just about labeling. Maintainer is something which is deprecated option. You can put a label basically and have that. Now, if I want to tell some information that so this is actually opening some port 80. So Docker PS, if you see, it's not telling that which port I'm actually opening. So if I want to tell that so which port I'm actually opening, so then you can go and say that I am actually opening 80 port. Okay, so now you can go and give Docker build and just give Docker run and then Docker PS. Now you see this is just an information only. It's not really doing anything. Previously also without the information also we're actually opening and hitting that. It's happening. It's only the information here. Okay, so there is nothing more than that. Okay, so and I would like to go with one more option before actually starting, and then we'll cover the later actually everything. But I want to jump onto the project. Okay, so while to jump onto the projects, I require one more option here. So which is something called as environment. So to keep the environment variables. Okay, so env, and you just do that. If you just give env, so how do you do that is env. So you give your variable and the value. So that variable will be shipped into the Docker image when it is actually making. So it's not okay. That's okay. The very important option here is add. So add is basically to copy some content inside our image. So then we use add. Okay. So now I'll just go for index.html and from I'll say wait. And I'm giving hello world and then save and quit. Okay, so Docker run vim Docker file. So now I want to copy or before do that I want to go ahead and run. I want to run rm-rf slash where is the location usr var ww slash var slash ww slash html slash star. You remove all the content and you add the content of index.html2 slash var slash w slash html slash index.html. Okay, save and quit. So now what I'm doing is I'm copying my own content. So previously when I do curl, I'm getting some default content. Now I want to get my own content, which is hello world, but I want to copy it at the time of making the image. So then I can go into Docker run -d. You do this, Docker PS, and you go with this one, and Docker inspect. You do this, Docker by Docker. All if you do that, you're going to get your hello world response. You can copy your content into the imaging while making the imaging. Okay, or you want to ship some content with the image. Okay, how do you do that is you add or copy. Two instructions are there, so you can just do them and you copy some content and yeah, you're ready to go. Okay, now using these options, okay, so we wanted to go into our project and we want to make the Docker files. So we'll change little strategies while making that, and what are those and why do you require those? We'll talk about those particular time. So mostly I'm done basically tomorrow. So what we're actually going to do is we are actually going to go into the project and start making the Docker files, and we'll start shipping the Docker images. Okay, so we'll do that and then we'll jump onto the Kubernetes platform basically. I hope today is Thursday, right? Thursday, Friday. Yeah. So mostly tomorrow we'll try to talk the Docker imaging, and next week we'll start the Kubernetes platform basically. Okay. I think that's all from my side. Yeah. Any questions? Okay, I see one question in the chat, I think. Yeah. Oh, you want right away? So I'm still modifying them. So I wanted to share at the end. So if you want right away, also I can share it. So your wish. That's fine now or later. Later is okay. Yeah, yeah. End of the day, I will share it. No doubt. Yeah, yeah. All right. So see you in tomorrow's session. Okay. Bye. Good day.